Hey guys, it's Mr. Stark here. This is one of the labs in Moodle. As things start to get a little bit more complicated, what you're looking at here is a diagram that's in, like, I don't know, lab number 7 or 8. And I'm going to skip some of the easy ones so I can get to just the harder ones as they start to get harder. What you're going to see here is 2 start buttons and a coil, control relay, and a light. Now, this start button is in parallel with that start button. That's the proper way of drawing it. This control relay and this light are in parallel with each other. They have parallel lines, so there's a parallel run. And if you look, here's a series line in between them. Now, how this circuit looks on paper is quite different how it looks in the lab. So here's my control relay, and you can see there's 2 wires that come into the feed side of the coil and 2 wires that leave the neutral side of the coil. Up at my light, you've got 1 wire into the green light, the neutral home, and it gets a little funny and fuzzy. This is why we got to really have something to look at in the lab. You've got a start button, and you'll notice 4 wires on this start button. 2 on the first screw, 2 on the second screw. When you get up to the second start button, there's only 2 wires on the start button. How does that look with the drawing? Well, it's the same way I wired it. I taught you guys that when we're wiring ladder logic, we work from the top, left, get the left side done, and then finish it. Maybe you can come around here and then back over. So the way this wire goes is there's a wire that comes from the feed into the first screw. Off of that same screw, there's another wire that comes down to the first screw of that start button. The second start button has 1 wire leaving, coming back to the first start button, and then it comes out of this screw again into the control relay. Then it comes out of the control relay again and goes down to the light. And the path home is just the neutral coming into the neutral side of the coil, coming out of the neutral side of the coil into the light, and it's already back home up here. When you're looking at it in the lab, this represents the same thing. So we've got the first wire coming in from the feed into the first screw of the start button, and off that same screw we leave and go to the first screw of the start button in the second enclosure. That's what we did. We came in, then we came out again, and then we ended here. So there's actually 2 wires in this screw, 1 wire in that screw. 2 wires in that screw, 1 wire in that screw. Kind of hard to see until you really do the point-to-point yourself. We came off that second button back to the first button. So here we come off the second button, back down into the first button, and then we come off that other screw of the first button, which is here, all the way over to the coil. We come out of that button, or that screw, I'm sorry, and we came all the way over into the coil. Then we come off the coil into the light. Off the coil into the light. That's where the light's tied in. And then the neutrals for the lights are just one goes into the other, and then it comes back home. Here's the neutral. It leaves the light. We come into the coil neutral, and then come off the coil neutral, back home. How does this work? After all that, and there's a lot to it, and this is still a simple drawing. How does that work? Either, look at the bottom, either start button could be pressed to turn on the relay and the light simultaneously. And I'll hit this start button, the relay and the light both go on. I could hit this start button, the relay and the light go on. So the parallel start is being able to start a motor from distant locations in 2 different locations from either button. Very handy to have that circuit in motor controls. And if we look at if we trace this out, as far as what we're really seeing on this drawing, as soon as I press this button, just imagine that this closes, and then these electrons that are here can now go over here and down this line, energizing both the coil and the light. If I erase this, because we know we got to hold that button for now, same thing down here. The electrons are coming all the way over to here. They're sitting here. There's nothing stopping them up to this point except for this open contact of the start. When I press that button down, these electrons then take this path all the way up. Some go there, some go there. When we wire things in parallel, one of the rules of a parallel circuit is that the voltage is the same anywhere in the circuit. So 24 volts is going here and 24 volts is going there, giving equal voltage to each load. We erase this, we put this back to what it was normally, and you've got 2 start buttons that do nothing unless you press one or the other. Doesn't matter which one you press because there's a path for current on either one when you make that circuit. Hopefully this helped a little bit, and I'll see you at the next one.